So we're going to do one more example of how to justify or prove the steps you are taking in an equation. This is, again, the precursor to proofs in geometry. So we talked about these steps already, that we want to begin with the reason for why we're setting up the equation that way, and then we prove each step using properties, definitions, postulates, or theorems. We're mostly using properties because these are more geometry things that we're headed for. And then we have to remember that if we want to justify each step, we have to look at the step above it in order to understand what we did to arrive at the new step, okay? So one thing we need to discuss a little bit here is the angle bisector definition. An angle bisector is not something we've discussed, or we just talked about it briefly. An angle bisector is simply a ray that divides the angle into two congruent angles. Okay, so for example, this ray right here, ray LM, it cuts this angle KLN, which is an obtuse angle. It's a big one. So we're just going to say ray LM is an angle bisector of angle L, angle KLN. Remember, L is the vertex, so it has to be in the middle. Okay? All right, so then what that means is that this angle and this angle are congruent. So angle KLM, it's this angle here, KLM, is congruent to angle NLM. Okay, so that's going to help me because knowing that this is an angle bisector is going to allow me to set these equations up now, okay? Because I'm told that this angle here and this angle here must be congruent because they were formed from an angle bisector. So that's what it says right here. Anytime you see the word bisect, bisect means cuts it in half equally. So LM, ray LM, bisects angle KLN. That's the given information that we're told, okay? So I am going to set up an equation based upon that. But in order to do that, I have to understand what this means. Well, this means that angle MLN is going to be equal to angle KLM, okay? We just said that those were equal. Why? Well, that is the definition. Remember, we said you always have to begin by telling why you're setting up your equation. Why am I going to set up this equal to this? Well, because this equal to this angle equal to this angle is the definition of an angle bisector. The fact that we had an angle bisector here made us set it up this way. Because what is the definition of an angle bisector? Two angles that are congruent to each other, okay? So that's going to allow us to set these equal to each other because of this, okay? You always have to give a definition or a reason why you're setting up your equation that way. Okay, so just like the previous example, I'm going to replace angle MLN with 4x because that's what it says MLN is. It's 4x. And I'm going to replace KLM with 2x plus 30 because that's what it says KLM represents. So that's simply the substitution property. I just substituted in the values for the angle names. Now, once I do that, then look at the next step. What's different? Well, if you look at the left side turned into a 2x. And the right side no longer has a 2x over there at all. How did that 2x go away? Well, if you were solving this, you would have subtracted 2x from both sides so you could get the like terms on the same side. So if I subtracted the same thing from both sides, that is again the subtraction property of equality. Subtracting the same thing from both sides is the same thing as keeping the equation balanced. So that's simply the subtraction property, okay? And then, how did I get from this to this? How do I solve for x? Well, you probably would know that you would divide by 2. 2 divided by 2 would just be x, and 40 divided by 2 would be 20. So the fact that x equals 20 was arrived at because of the division property of equality. It allowed me to divide the same thing from both sides and solve the equation. So that's just another example. That's some of the things you're going to be doing on your homework. They're going to give you the steps. They're going to show you what they did. You have to give the justification for each step. The first step is always why you're setting it up that way. And then the steps after that are simply properties. Okay? And that's when we're dealing with geometry concepts. If they just simply set up an equation, okay, then you would not have to worry about that. They would have already kind of got it started for you, and you would immediately jump into your properties. But if you have a geometric figure that you have to set up, then you're going to have to give a reason for why you're setting it up that way. And then you jump into your properties.